Now, here's why this whole thing is going on, that we're now talking about a different coordinate system, because basically sometimes it's easier to work in this other system.
Easier.
And you're not really going to see that actually happen until calculus, and maybe not even for a while in calculus, like Calc 3 or 4.
But you know what? Let's just cut down to the chase here. It's easier to write the equation of a circle in polar form than it is in Cartesian or rectangular form.
Right, and that's something that we're going to look at.
Right, and that's the
later.
easiest application of that one.
And so because of that, because basically what we're doing is saying that sometimes it's easier to work in polar versus rectangular. Okay, we'll call our normal way is rectangular, this is polar. Okay, because of that, we need to be able to switch between the two.
Right, yeah, you got to go back and forth.
So these are our conversion-y things,
Hey,
basically.
wait a second. X equals r cosine theta.
That's like...
haven't we been using that?
Theoretically, they may have this written on their unit circle card somewhere.
Right.
So they just moved the r over to solve it for x. They just moved the r over to solve for y.
Y equals r sine theta is the same thing.
Yeah. And this, Pythagorean theorem.
Hey, and tangents,
I think we've
used all of this.
That's why we've used most of it recently, even with vectors, which is probably why it's in this section.
All right.
So example 3, we want to find the rectangular coordinates with the given polar coordinates. Now, we said there's a lot of ways you could basically take the same rectangular coordinate and write it with polar. There's a lot of ways you can do that, but polar only has one thing in rectangular. Okay, so
only
like
one?
this,
there's
only one xy that goes with this r theta.
Are you sure?
I'm positive.
I'm positive you're positive.
Okay.
I was just messing around.
So, but this is actually really simple. If we have r and theta, we just need to, because we want rectangular coordinates, which is x comma
just
y.
plug them in there.
Plug it in.
Hey, that sounds like it could be a commercial.
It could be. I could be rich someday.
Yeah, but here we are. Okay, so 3 sine 5 pi over 6.
I'm just writing it this way because this is our point, x comma y, right? That
this could be on a no calculator portion of something BT dubs.
It could be, because you could look at your unit circle at 5 pi over 6, and the cosine of 5 pi over 6 is
negative square root of 3 over 2.
Square root of 3 over 2.
So 3 times that.
So negative 3 square root of 3 over 2.
Yep.
This would be
1/2.
Positive 1/2.
Yep,
so
positive 1/2.
3 halves.
Yep.
So there you go. And if it is on your unit circle like that, then put the actual square roots and fractions. Don't give us a decimal.
If you give us a decimal, it will not be correct.
Right. And we'll try to specify by, it's really easy to know that you should have like square roots and stuff if it is on a no calculator part.
Right.
But all right, so let's try this one.
Okay.
Same deal, but this time we will have to use a calculator because I don't know if you know, negative 200 is not on the unit circle.
I might have a calculator on my phone. Since I left the other one, I don't know where.
Oh, that's not awkward.
It's not...
Well, 2 cosine negative 200, I happen to know off the top of my head, is negative 1.879.
What? How did you do that?
And 2 sine negative 200 is 0.684.
Got it. 2 times...
Just off the top of my head.
Whoops. Okay.
I'm lying. I have it written down.
200
I came prepared.
Cosine times 2. Negative 1.879.
What's going on behind us?
Bears, be careful.
Okay. I just noticed that they were behind us.
We don't, you gotta watch out.
Oh,
you gotta watch out.
Kind of cold in here.
It's the Arctic. Bundle up. Yeah.
Did you get your calculator to work yet?
Yeah. If they can't see you, they can't eat you.
All right, converting from rectangular to polar coordinates. So we would go backwards here. This is x and y. And typically, I guess they'd have to tell us what kind of angle they want from us, like between 0 and 2 pi, right?
Yeah, totally. Whatever you said.
Something like that, maybe. So... Watch out, there's a chair there.
There's a chair there and a polar bear back there, so...
We would now use the right side here to find r and theta. So negative 1 squared plus 1 squared, square root that,
Square root
r.
of 2. See, if you don't put that negative in parentheses, you get 0 right there, and that's bad.
That's bad.
That's
that
bad.
does not have an r value of
1
0.
squared plus 1 squared equals 1. Psh.
Yeah. Now theta equals inverse tangent of y over x. I feel like we just did this with like vectors.
I mean, it's quite possible.
Isn't this exactly like finding the magnitude and direction of a vector?
I feel like, yes.
Hey, inverse tangent of -1, we could actually do the
It's
unit
negative
circle
pi
for
over
that.
4.
It is, but if we're trying to go between 0 and 2 pi,
So it'd be 7 pi over 4.
7 pi over 4. So one possibility for our point is square root of 2 comma 7 pi over 4.
And that's how you would leave it. You would not decimal that out. That is
No.
an exact answer right there. If you decimal that out, the bears will
The bears
eat
will
you.
eat you, yeah. And we could have, though, gone the other side and done a negative, but why bother?
I mean,
If it just wants 1, why
if
bother?
if you want to
If
be
you
a
wanna.
cool guy, you could do it again and get another one.
Yeah, totally.
This one's weird and easy, but looks hard all at the same time.
Right, and so we can do it the same way we did this last one, but sometimes it's helpful to draw a picture, and it gives you some practice of, like,
Drawing in rectangular form.
I don't know.
Okay.
Yeah, my bad. So this is a rectangular point, -3 comma 0.
There it is right there.
If we think about what theta would be to get around to
have
that,
to be pi.
have to be pi.
Theta's got to be pi.
Okay, and then how far out is it? It's 1, 2, 3.
It's 3.
Okay, that only works if it's on a quadrant line.
Right.
Otherwise, you still have to do the Pythagorean theorem,
Right.
even if you can figure out what angle it is.
But we didn't really need to do Pythagorean theorem.
Yeah,
this
because
time.
it'd be -3 squared plus 0 squared. Square root it. That's just 3.
Yeah.
Okay.
There you go. Set. Okay.